Hey everyone, this is our video on scientific notation. So by the end of this video, you should be able to express numbers in scientific notation or expand a number out of notation. So first, let's talk about what scientific notation is. So this is a way in science, and really in math, but you know, we're a science class, so we look at it there, to write really big or really small numbers instead of having to write a billion zeros. Excuse me, I got the hiccups. So for large numbers that you have, you're going to have a positive exponent. And for very small numbers, your exponent should be negative. When you write a scientific notation value, the number out front, which is called your coefficient, should always be between 1 and 10. So if you look back at our previous lesson and I used 14 times 10 to the 9th nanograms, but I rewrote it as 1.4 times 10 to the 10th, that's because of this rule here that we want it between 1 and 10. Do not drop any whole numbers. So even if I had like 14.2697, we would use 1.46297 or whatever numbers I said. Don't drop any whole numbers. Only when we round and do math, that's when we adjust our whole numbers. So you can expand numbers out of scientific notation by moving the decimal based on whatever your exponent is and then adding zeros to take up those spaces. So this is a number that is very, very common in chemistry. This is called Avogadro's number, 6.02 times 10 to the 23rd. So this right here is our coefficient, and as you can tell, it is between 1 and 10. Okay, 6.02 does fall between 1 and 10. This exponent right here is positive, which means this is a large number, a very big number. So what you would do if you wanted to take this out of scientific notation, you would have 6.02, and you would move this decimal 23 places to the right, okay? Because we're a positive number. So it would be 1, 3, 4, 5, 6, 7, 8, so on and so forth until you've moved it 23 places. So now we're going to try this example. So let me get these boxes to show up. Okay. So we are going to express this number in scientific notation. So we are putting it into scientific notation. It is a big number, so we should have a positive exponent. So our first step here is to write the coefficient. Okay, so we're looking at this part of our number. So we're going to make this to make sure the number falls between 1 and 10, you always put the decimal after the first whole number. So we've got 1.267. I did not drop any whole number. And now I just need to count how many places we have after the decimal. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is our exponent. So times 10 to the 9th, because we took up 9 spaces. 1, 2, 3, 4, 5, 7, 8, 9. Yes. So that's our answer. That's all we have to do. And now I want you to express this number. You can pause the video so you can try this. Express this number in scientific notation, but pay attention. This is a small number. So know what kind of exponent we should have, you know, and how we write that exponent. So now let's talk about how to do math with scientific notation, because it is a little different. Not super different. You will have a calculator, so you can always just check yourself with a calculator. But if for some reason you want to try to do some of this by hand, just to make sure you can. For addition and subtraction, the first thing you have to do is make sure that all your exponents are the same value. If they're not the same, you can't do the math for addition and subtraction. And then once your exponents are the same, you just add or subtract your coefficients, and that makes your math a lot easier. For multiplication, you multiply the coefficients, and then you add the exponents. Okay, so we should be making bigger numbers when we multiply a lot of times, bigger versions of whatever numbers we have originally. So make sure you multiply, I should say multiply, not multiple, multiply the coefficients and add the exponents. So then for division, which is the opposite of multiplication, we should be doing the opposite. We're going to divide the coefficients and then subtract our exponents. So here's an example of addition and subtraction that we're going to, oops, sorry, let me see if I can go back. There we go. So let's go through this one really quick. Let me get my little pen. So we're going to add these up, but as you can tell, our exponents are not the same. They are not the same. So what we're going to do, excuse me, is we are going to move this dot to the front, and we're going to make this 0.88 times 10 to the negative second. Because since it's a negative exponent, already when you move it more towards the negative side, you're adding to that exponent. So we fixed that. So now all you have to do is you have to add up your coefficients. So 2.6 plus 0.88, which will give you 3.48. So you're going to add this and this. So 0.88 plus 2.6, and that's going to come out to 3.48 as your new coefficient. That is still between 1 and 10, so that's good. And now all we have to do is add times 10 to the negative second. The exponent does not change here. Okay, so that's all you have to do. Make sure your exponents are the same. So you may have to move your decimal while you're trying these. So now let's try an example of math done otherwise. So here we have to follow our rules for multiplication. So for multiplication, we're going to take these coefficients and we're going to multiply them. And we're going to take our exponents and we are going to add them. Okay, so when you multiply these, we've got 1.72 times, and I'm doing this on my calculator as we're doing this video, 1.72 times 3.33. So my new coefficient comes out to 5.05. Okay. When I add these up, I'm adding 6 and 5, which means we've now got 10 to the 11th power. So my answer is 5.05 times 10 to the 11th. Now, had this been a negative 5, okay, let's just say it was a negative answer, we would have done 6 plus a negative 5, which would have actually been 10 to the first. Okay, does that make sense? Like, pay attention to the sign on your exponent as well, because that will change this addition or subtraction. So now you have an example to do, which is division. So follow your rules for division, pause the video, and try this example. You'll be able to go over it with your group mates in a minute. So now, guys, after that practice, you should be able to express numbers in scientific notation, expand out of